Hi, this is Kenneth Wong, Senior Editor for DE 24/7. Digital twins available from your tablet. Digital twins that let you experience an underwater world. And digital twins of autonomous vehicles. These are just some of the things to discover at Siemens Realize Live in Mandalay Bay in Las Vegas. So come with me for a tour of the show floor. This is a prosthetic arm called TrueLimb from Unlimited Tomorrow, a company making low-cost bionic arms for amputees. They are personalized from sockets to fingertip and extremely durable. It comes with a breathable, comfortable socket lined with 30 or more sensors for intuitive, precise control. Easton LaChapelle, the company's CEO, was one of the keynote speakers at the conference.
When I was 14, I came with an idea to create a robotic hand, pretty much piecing things I had around the house together. And this incredible moment happened at the 2013 State Science Fair in Colorado. I met a small girl that had an $80,000 prosthesis, and I just could not believe this. I entered a robotic arm that I made for a couple $100, and it was more advanced than the prosthetic device that she had. Tapping into the NX additive manufacturing module is going to be paramount for our success, making sure we can fit as many sockets and devices into each build as possible. Siemens allows us to do more with less, really democratize our technology further, eliminate bottlenecks that we know we're going to face in the future. Every year, we want to add a zero onto the numbers that we're doing. We want to exponentially grow the number of TrueLimbs that are in the world.
Digital twins or digital replicas of the real-world products live in immersive 3D environments, but the way you interact with them is most likely through tablets, augmented reality, and virtual reality hardware. Here is one example.
Yeah, so the Simrod vehicle over here is a kit car that we have used as a demonstrator for various technologies, both on the simulation side as well as on the testing side with the SimCenter portfolio. So the app is basically a way for us to showcase different things that we can do. So what I'm going to do over here is scan this particular QR code. And if I step back, you can see all these bubbles appear. So I'm going to click on one of these. In this case, what you see is an overlay of the battery system, and you can navigate and look at different aspects of battery design and performance engineering that have been done on this particular battery pack using SimCenter. So you click on that, and here is a brief view of battery design work. I think in this particular case we're doing some thermal analysis. So here is the suspension system overlaid on the actual vehicle, and we can do all kinds of things. So here's the instrumentation that's happening to do road load data acquisition. You take the vehicle out on the track and collect data, and then you feed that data into a simulation model to do fatigue life prediction.
This looks like a driving simulator, but it's more accurate to say it's a non-driving simulator, meaning this is a setup to simulate and test self-driving cars.
Yeah, what you see is a driver-in-the-loop system together with a hardware piece. So it's a driver-in-the-loop, it's a hardware-in-the-loop, where we bring automation together with manual control of a vehicle. So everything you see here is rendered by SimCenter Prescan. It's a world and sensor simulation tool. So our users are using our tool to build up worlds, scenarios, and generate sensor data, just to create the same data that real sensors will provide to the users to feed into their perception and control algorithms to speed up the development of automated systems in the end. It can be ADAS, ADAS+, autonomous vehicles. That's what our tool is used for. We bring in a hardware piece that's actually doing the perception. So we do the control, the camera does the perception. So this is typically a camera that you see nowadays on a real vehicle. It's mounted below the rear view mirror, and it will do some detections of the surroundings. For instance, lane line information and object information in the scene. The camera will perceive the environment, will send it to our control stack, and our control stack will make sure that our car is currently driving autonomously. It will follow the lane line, it will brake for objects, it will speed up to the set point speed with the adaptive cruise control if there is no object in front. So it's driving kind of in an autonomous mode at the moment. Based on the information coming from the camera that's pointed on the screen, where a visualization is rendered coming from SimCenter PreScan as well. We don't call it fully autonomously because it will not drive from A to B. It's an automated system still, but the driver doesn't have to do any input. The car will just drive on the highway and will just follow its lane line without the need to involve the driver in the whole setup. Actually, two things. One thing is that you drive manually yourself to a certain situation that you are looking for, and then you let your system take over control and check how the system will take over the control. That's one part. The other part is when the system tells you to take over control, which is typically still the case for ADAS Level 2 and ADAS Level 3 systems, that it will give a warning, take over control, then you can test what's going to happen. And if the driver is able to take over control in a potentially unsafe situation, but it can also be an unstable situation, so where the system loses control of the steering wheel, just like a human can also have. So for instance, if you have a certain object in the way and the system is trying to avoid the object by giving steering wheel input, and you will end up in a rollover, then the system will warn you that it feels it gets unstable, and it asks you as a driver to take over control to bring it back into a stable situation.
Here is an example of the use of VR to understand what it's like to grow crops sustainably underwater. This is the VR experience of the works of a startup called Ocean Reef Group.
The ultimate goal of Nemo's Garden is to provide the option for more food for the population.
Out of the whole world we live in, only 11% is arable land, where we can effectively grow plants.
70% is covered by ocean. Why don't we try to use part of the ocean to make more food? Nemo's Garden is an underwater lab where we are trying to experiment a new alternative agriculture.
Our accelerator platform matches so well with what they want to do.
Our innovation cycle is accelerated using Siemens technology by allowing us to test the new ideas in the virtual world.
We've seen benefits in understanding the flow of water around the shapes of our biospheres. We understand points of stress on our chains and on the structure around the biosphere. We also understand how the different interactions of the evaporation and temperature and all the physical factors that come into place act on the plants thanks to the ability of MindSphere and the digital twin to replicate our system.
For example, we used our CCM Plus to do external simulations of the design to be able to help us calculate how much drag and volume we would be getting off of different design shapes. We were able to figure out the most manufacturable design that gave us the largest grow volume while also reducing the amount of impact that we had on the environment.
All of these digital twin experiences have to be powered by professional hardware from Siemens partners like HP and NVIDIA. So let's take a look at some of the systems on display.
So digital twin is this technology which enables manufacturing companies to really understand their products very, very well, right? Connecting the physical to the digital, making sure that you are capturing all the data, feeding it back to the product development phase, right? To make sure products are optimized and working at their best. So for doing this, some of these processes can be really intense on the hardware side. You're capturing all of this data, you're feeding it back to the digital models, right? So making sure that you have the right computational technology in terms of CPUs, in terms of GPUs, to really power these digital twins is critical. And that's where NVIDIA with its GPU acceleration can really provide benefit to the users in terms of creating these rich, immersive digital twins, right? Because you want to get a real life experience from these products. And that, I think, is the key to making successful digital twins and digital transformation. This is the Z8 Fury machine, which supports up to 4 NVIDIA graphics cards, workstation graphics cards. What you see here is our 6000 series graphics card. These are our flagship cards. Each card has 48 GB of video memory, so it can support massive models, CAD data sets, rendering, visualization type of workflows, and increasingly CAE, or engineering simulation, which is being done on GPUs. So for example, Siemens Star CCM recently introduced GPU native solvers. So instead of relying on CPUs for running these simulations, it is being entirely done on the GPU, which is 15 to 20x faster as compared to running it purely on CPUs. At the same time, it is consuming less power and allowing simulation engineers to run more iterations. So it makes them more efficient. It allows them to test more iterations to come up to that optimum design.
The really cool thing about this, though, is that it also has some amazing power supplies, dual 1100 watt power supplies. So the most demanding task that you used to want to send up to the cloud to run on servers, you can do at your desk without having to push that data up, bring it back down. It's just an amazing device. But my personal favorite is our ZBook Studio. And it's I think this is like an engineering feat. The display's amazing. This happens to actually have an NVIDIA RTX A5500 GPU in it, which is, so it doesn't matter what you're doing, whether you're doing a design, you're doing photorealistic rendering, you're doing CAE work, you can do it on this very compact mobile workstation. Now, one of the things that's pretty cool about this too is that you'll see this keyboard, and but it's not just like a gimmick. It's this really cool backlit RGB keyboard. But from a practical standpoint, what can you do? You can actually create templates. We have something called Light Space, and you can program this for your hotkeys. It's really nice. It works on our ZBook Fury as well. It's super cool. So I love this. It's my favorite ZBook ever. So this is the Z40C, and what's interesting about this is most people, you'll have 2 displays on your desktop. A lot of thought went into the design of this to act as not only a hub for powering other devices. This actually gets powered off of any of our devices that have a USB-C cable, but it actually works as a KVM as well. So I can have 2 computers hooked up to this, and it will automatically, I can switch between the devices on a single display, or I can have multiple displays up with one workstation on one side of the screen and another workstation on the other side of the screen. And of course, it's got audio, and it also has our high-res webcam built into it as well. So it's very versatile. 40 inches. You know, there's a lot of desire for people to have bigger and bigger screens. And from the feedback that we've gotten from the field right now, people think this is almost like the perfect size.
Well, that's a wrap from Siemens Realize Live from Las Vegas. I'm Kenneth Wong for DE 24/7. For more engineering and simulation related news, go to Digital Engineering 24/7. That's digitalengineering247.com. Till next time, bye-bye.